My name is Dasha Metropolitansky, and I'm a research data scientist in the Microsoft Special Projects Resilience team. I developed a system called Claimify, which is a claim extraction system. You're probably wondering, what is claim extraction? Well, there are two keywords, claim and extraction. A claim, as I define it, is a simple factual statement that can be verified as true or false, and extraction is the process of breaking down a text into claims. To give a simple example to illustrate, let's say that you have a sentence. Some notable examples of technology executives include Satya Nadella and Bill Gates. If I had to break this sentence down into claims, there would be two of them. Satya Nadella is a technology executive and Bill Gates is a technology executive. So this is a really simple example, but you can already start to see some of the properties that we might care about when we do claim extraction. One of them is that I got rid of this word notable, because what does that even mean? That's not something that I can verify as true or false. The other is that I created separate claims, one for Bill Gates and one for Satya Nadella. This is because we want claims to be the simplest possible independent statements. So taking a step back, Claimify basically takes in a text of any length. Usually these texts are much longer than the example I just gave you, which was just a sentence, and it'll take that text and decompose it into these high-quality claims. I'm working now on a system that does hallucination detection. So let's say that your question answering application answers questions based on some source documents, like news articles. You want to make sure that the language model is answering those questions based on the source documents, not just making things up. But that's a really hard evaluation to perform when you have a paragraph or multi-paragraph answer that has so much information in it. Now imagine if you could distill that into a simple set of standalone factual statements. It becomes much easier to then check those independently. But this is not just about hallucination detection. You can do other sorts of evaluations as well. So back to the use case, you're building an application. You want to know how relevant the answers are to the question that was asked. If this answer contains 20 or 30 distinct points, it's so hard to say how relevant the entire answer is. Maybe some points are relevant and others aren't. But if you can take these individual factual claims and say, this one is relevant, this one isn't, you can easily aggregate that into one composite measure. Our team is also using the number of claims in the answer as a proxy for how comprehensive it is. So to summarize, why does claim extraction matter? Because it unlocks the ability to evaluate long-form content generated by language models. We don't try to do claim extraction on the whole text at once. We actually break it down into sentences, and we do the claim extraction on each sentence independently. Now, to ensure that those sentences are interpreted accurately, we include some context, which is basically a window of text around the sentence. So that's number one. Number two is we don't treat claim extraction as one monolithic task. We break it down into three parts: selection, disambiguation, and decomposition. Selection means we're filtering out sentences that do not contain any verifiable claims. So for example, if I gave you the sentence, companies should embrace AI, that's not a factual claim, it's an opinion, so we would filter it out. Secondly, we have disambiguation. This is basically detecting whether there's ambiguity and then deciding if there's ambiguity, can it be resolved using the context, or flag that it can't be resolved. Ambiguity here just means there are multiple plausible interpretations, and depending on which interpretation you pick, you're going to get a very different set of claims. This is one aspect of Claimify that is really unique and powerful, especially the ability to determine whether or not this ambiguity can be resolved. And then the last stage is decomposition, which takes the disambiguated sentence and breaks it down into these simple standalone factual statements. So let's take a closer look at Claimify in action. Imagine you're developing a chatbot. You ask it to provide an overview of challenges in emerging markets, and it generates this answer. Assessing the quality of the answer is really hard. It's packed with information, and there's no gold standard to compare against. Instead of processing the entire text at once, Claimify extracts claims from each sentence independently. We include context for each sentence to ensure accurate interpretation. To recall the sentence, the UN found that the resulting contaminated water caused many residents to fall ill, highlighting the need for improved water management. The baseline prompt ignored the phrase highlighting the need for improved water management. It only extracted claims from the first part of the sentence. However, Claimify reasoned, quote, the sentence could be interpreted as the UN found that the contaminated water caused illness and also highlighted the need for improved water management. Or it could be interpreted as the UN only found the contamination and illness, and the author is adding the interpretation about the need for improved water management. In other words, this may or may not be a verifiable claim. Claimify decided that the context did not clearly support either interpretation, so it flagged the sentence as cannot be disambiguated and did not proceed to the decomposition stage. Here are the sentences where at least one claim was extracted. I'll highlight a few examples. Recall the sentences about Argentina's inflation, where the baseline missed the claims about economic hardship and the prediction of rates greater than 300%. Claimify did not miss these claims. Also, the baseline just said Argentina's currency value has plunged. Claimify correctly specified that inflation has depreciated the currency. Consider the sentence, countries like Afghanistan and Sudan have experienced similar challenges to those of Libya, where the baseline claims never specified what those refers to. While the context discusses public health crises, flooding, and contaminated water, so Claimify made specific claims about these issues. In the sentence, Nigeria is striving to become self-sufficient in wheat production, but is hindered by climate change and violence. The baseline had claims like, Nigeria's wheat production is hindered by climate change and violence. Claimify captured that it's Nigeria's efforts to become self-sufficient in wheat production that are being hindered. So one of the most popular use cases of language models is generating long-form content. Unfortunately, it's really hard to evaluate the quality of that content. Claim extraction can help, and Claimify is a really powerful tool for generating high-quality claims.